So in the last class we were talking about relative density. The ideas of mass, volume and density, they were discussed in detail. And what is relative density? Let us do a short brief revision of that. Well, relative density is the ratio of the density of any substance divided by the density of water at 4 degrees Celsius. So if I am measuring, for example, the relative density of kerosene, so the relative density of kerosene will be density of kerosene divided by density of water at 4 degrees Celsius. And density is mass by volume, and since we consider the same mass of water as the volume of the substance, this expression can also be written as mass of the substance whose relative density we are measuring divided by mass of water at 4 degrees Celsius. Now to measure relative density directly, there is a certain apparatus, a certain arrangement which is known as the relative density bottle. So what's the relative density bottle? It's much like a flask, and near the opening there is a capillary tube. Near the opening we have a capillary tube. So whatever liquid whose relative density we are trying to measure is being poured into this flask. Once the flask is filled with that liquid, the opening is completely sealed with a cork, and during that, if there is any excess liquid, it overflows out through the capillary. Now to find out the relative density, what they do is, first of all, they measure what is the mass of this empty bottle, this empty flask, when there is no substance inside it. Suppose that mass turns out to be m1. Maybe that is what we have measured. Next, we have to measure what is the mass of this bottle along with water. That is to say, this bottle or this flask is filled with water, and once it is filled with water, the new mass is measured, which is suppose m2. And then after draining of the water and cleaning the flask completely with distilled water, now the bottle is filled with the liquid whose relative density we are trying to measure, and the new mass has been calculated. Suppose it comes out to be m3. Then the mass of water in the bottle, mass of water, is equal to m2 minus m1, and the mass of liquid in this bottle is m3 minus m1. And as we know, the relative density is equal to mass of liquid divided by mass of water. The final expression stands as m3 minus m1 divided by m2 minus m1. So this is the relative density of a liquid as measured using a relative density bottle. You will find a corresponding numerical in your book explaining this. There is another device known as the hydrometer, and this hydrometer is generally used for measuring the relative densities of substances in a much quicker manner. So what is the hydrometer? The hydrometer is basically a structure like this. This portion, this tube, it's graduated, it is marked, and this lower portion, which is known as the bulb of the hydrometer, much like our thermometers, is made heavy by using lead shots. Generally, this entire structure is made up of glass. The cylindrical stem here is graduated, and the bulb that is filled with lead shots. At times mercury is also used. The function of this lead shots or mercury is to make this one heavy so that it can be used for taking readings. Now how is the reading taken? Suppose we want to find out the relative density of a substance. So we take a jar and we fill that jar with that substance whose relative density we are trying to measure, and then we insert this hydrometer into the jar. Now based on that how much of the hydrometer is outside the surface of the liquid, that is how high it is floating or how low it is floating. Based on that calculation, one can find out whether this liquid has got a high density or a low density. That can be calculated by using that the markings here, the graduations are provided here. By seeing the graduations, we can come to know that what is the density of the liquid. So greater the density of this liquid, higher it will float, and smaller the density of the liquid, the lower it will come down into the surface, because this is due to something called upthrust, and you shall be studying it in class 9. So if there is a fluid and if I immerse a body inside that fluid, then when I am immersing the body into the fluid, it experiences something called upthrust. This upthrust is exerted on the body by the fluid in which I have immersed it. So because of that, there is a upward force which tends to push the body out into the surface. So greater the density of this liquid, greater will be the upthrust, and lower the density, lower will be the upthrust. A hydrometer which is specifically used for calculating or testing whether milk is pure is known as lactometer. So lactometer is a specific hydrometer that is exclusively used to check whether milk is pure. So relative density of a substance, which can be measured either by using a relative density bottle or by using this hydrometer, will help us know whether a substance will float or whether it will sink in water. So what is this flotation and sinking? So for flotation and sinking, you need to remember two cases. So suppose I again have a container like this with a liquid, and this is the solid in it. So let rho solid be the density of the solid body, and let rho liquid be the density of the liquid in which we want to check whether this solid will float or sink. Remember that if the density of the solid is greater than the density of the liquid, so if rho of solid is greater than the density of the liquid, rho of liquid, the solid will sink into the liquid. And if rho of solid, the density of the solid, is smaller than the density of the liquid, then the substance will simply float. So if you take water and on that water you put a cube of ice, you will find that the ice will float. That is because the density of ice is less than the density of water. But if you take a small spherical lead shot and you leave it freely onto the surface of water, you shall find that the lead shot will get submerged in water, it will sink. That is because density of lead is greater than density of water. Remember that just because a solid is sinking in one liquid does not mean that it will sink in all liquids. Okay, it all depends upon the density. A lead shot will sink in water, but if you take the same lead shot, you shall find that it will float in mercury. So it all depends upon that what is the fluid or what is the liquid in which we are trying to find it out. Now there are certain applications of flotation in our real life as well. This concept of flotation and sinking has got many such applications. So what are those applications? River water and sea water. So what is this concept of river water and sea water? As you already know that seawater means basically this contains a high quantity of dissolved salt. Seawater is salty. You have been studying this from your childhood. So seawater contains very high quantities of dissolved salts as compared to river water. As a result of this, the density of the seawater is greater than the density of the river water. Because of the presence of the salt, density of the seawater is greater than the river water. Therefore, you shall find that it is easier to swim in seawater than in river water. Density of ice is less than that of water. I had already discussed this, that rho of ice is less than rho of water. If you know the actual values, you shall know that density of water is 0.91 grams per cc, whereas density of water is 1.0 grams per cc. So density of ice is less. This is why ice cube floats on water, and it is the same reason that the icebergs, they float on water. Though a huge portion of the iceberg is actually underwater, not visible from top, but in general icebergs float in water. Another application of this concept of sinking and flotation is for the ships. Well, ships, especially the cargo ones which carry loads from one place to another, these cargo ships, they submerge more in river water as compared to that in the sea water. Why? Because sea water has a greater density. So greater density means it feels a greater upthrust, so it is easier to float in sea water. But in river water the density is small, so the amount of upthrust is also less, so the ship gets submerged. So if this is like river water and this is like sea water, suppose this is sea water and this is a river water, and if there is a ship, suppose this much portion of the ship is submerged in sea water, but when it comes to river, a greater portion of the ship is submerged, because density of river water is less than the density of the sea water. And for this reason, in the ships you shall find that there are certain safety lines. These are generally painted in yellow. These lines are called the plimsoll lines. The plimsoll lines is basically like a warning signal. It allows the captain of the ship to know that if the level of water crosses the plimsoll lines, that means the ship has a tendency of being submerged or sink. So the captain has to keep it in mind that the water level never crosses or moves above the plimsoll lines. It is easily found in all kind of ships.